Thanks for attending our webinar about Morningstar's string sizing calculator. This is Mark McHenry, along with Doug Grubbs, who will help answer any questions that you have during this webinar as time permits. So if you have a question, just go ahead and type it into the chat box at the bottom of your GoToWebinar pane. We will be recording this broadcast and emailing you a link to the recording before the end of day tomorrow. And we've also included this slide deck on the handout section of your GoToWebinar pane. So you can go ahead to that handout section and download it right now. Let's go ahead and take a look at the agenda for today. I'll start off with a brief introduction about Morningstar and our online string calculator. Then we'll take a look at how an off-grid system is designed and how the string sizing calculator fits into that design. I'll then demonstrate how to use the string sizing application on a website and how to interpret and share the results. And finally, we'll wrap up with a summary and a Q&A session. So who is Morningstar? Morningstar is a U.S. company that conducts business through authorized distributors and dealers all over the world. Since 1993, we've been a leading supplier of solar charge controllers and inverters with the same ownership, same management and distribution partners throughout our history. Over 4 million Morningstar products have been supplied worldwide in all types of residential, rural electrification, mobile and commercial and industrial applications. And we pride ourselves on our wide diversity of high quality, reliable, and innovative products. You can see here that Morningstar has two product series. The Professional series contains products that are offered globally in every country. Many of the Professional series controllers have communications and data logging capabilities, as well as special certifications that are not found in other charge controllers. Then on the right, you see the Essential series. This is a line of Morningstar controllers that's based on the Professional series, but with features catering to smaller residential or recreational projects rather than industrial commercial systems that might require special certifications or data communications capabilities. And unlike the Professional series, the Essential series is not offered in the US and Canada. And before I present Morningstar's string calculator, I want to ask each of you to answer the question, when did you first use Morningstar's string calculator? So I'm going to launch a poll. And that should be appearing on your screen right now. So if you go ahead and start picking one of those selections. Was it 3 years ago or more, less than 3 years ago, or have you never used Morningstar string calculator? So I see the votes coming in, and there's some more coming in. I'm going to leave this open for about another 5 seconds, then I'll close it out, and we'll see what type of results we have. All right, very good. Let me close this out now. And I'll share the results. Thank you for doing that. It looks like we have about 80% of the attendees here have never used the string calculator. So thanks for sharing that. Let's go ahead. Go ahead with the presentation. And I'm going to answer these 3 questions throughout this presentation. Number 1, what is the Morningstar string sizing calculator? Secondly, why is it important? And third, how to access and use it. But first, what is the string calculator? The string calculator is a web page tool that helps you determine the number of solar modules to arrange in series and parallel according to your system loads, also according to the batteries that you're using, the module type, and the solar charge controller, and historical temperatures at your site. A series connection consists of 2 or more modules where positive ends are connected to negative ends, and a parallel connection describes a positive to positive or negative to negative connection. So the example on the right shows 4 parallel strings, 1, 2, 3, 4, and then 2 modules connected in series. The string sizer module database is updated with new module brands and models each quarter. We presently have over 100,000 module models in the database, but if you're unable to find your specific module in our database, you can have the option to input its specs manually, so you can still use the web page to perform your calculation. I'll share an example a little later to let you see what the string sizer's output results look like. These results will include notes about acceptable oversizing, as well as notes about configurations that may be problematic for your charge controller and your system. And this string sizing application shows or allows you to save and print and share the results page with others. And you can see here there are at least 3 reasons why the string calculator is important. Number 1, it determines optimal module configurations. Number 2, it alerts you about unsuitable module configurations that might damage your charge controller. And then 3, it helps verify that you've chosen the right battery voltages, modules, and charge controller for your system loads. There are several ways to access the string calculator from the MorningstarCorp.com website. You can click on Products from our website and then click on Tools and String Calculator to access it. Or you can access it from any of the product pages on our website by clicking on the string sizer hypertext link on the right that you see here. When you access the string calculator, this is what it looks like, minus the URL circled in red that I superimposed here. In order to input the proper information to allow this web page to deliver meaningful results, you or a third party needs to complete an off-grid system sizing exercise concerning your loads, batteries, array output, and charge controller. And this slide shows the steps that are involved with an overall off-grid system sizing design. During this webinar, we're not going to be covering the load analysis, battery bank sizing, or array sizing in a lot of detail because any in-depth discussion about these steps would probably be best handled by our distributors, and they do take a little while. Also, we're planning to have a joint webinar with one of our partners within the next few months, which will include system sizing, which will cover these steps in more detail. If you do have a pressing question about system sizing and design, we can refer you to a dealer or distributor who's best able to help you with battery and solar module options for your system. All right, here's a pictorial view of the steps that are involved with off-grid system design and where string sizing fits in. So you might say that string sizing is a subset of the overall off-grid system sizing. Before you use the string sizing calculator, you need to complete each step on this slide to figure out your inputs to the string calculator and to make better use of your results. So first you need to complete a load analysis, which involves determining the amount of power your electrical loads will draw on a daily basis. Then you can determine your battery system voltage and capacity depending on the number of days of autonomy you want for your system. From there you can determine your array sizing requirements. In other words, the power in watts your array needs to provide. That followed by your charge controller selection. And then you can use the string calculator to determine your module series and parallel configuration. I should also add that the string calculator can also help in making and verifying decisions associated with array sizing and controller selection. There are many off-grid design resources in addition to our distributors and consultants. And we'll share some on the next slide. So let me go ahead and forward to that. These are some common resources. I'll leave this slide up here for a little while. It's also in your handout section. Also, many other system sizing resources are available. And that said, let's take a quick look at the first step in system sizing design, and that's load analysis. We need to calculate the average daily DC energy consumption. If there are seasonal loads where the load usage will vary, we need to calculate the load usage for each month. If you have a PWM controller, you'll want to calculate load usage in amp hours per day. On the other hand, if you're using an MPPT solar charge controller, you'll want to calculate load usage in watt hours per day. And for loads involving an inverter or DC-DC converter, you'll need to account for efficiency losses. Then you simply sum up the power needs for all of your loads. After that's done, you'll need to determine the critical design month, which we'll take a look at on the next slide. Determining the critical design month is based on the design ratio between the average daily DC energy versus the average solar production potential for a particular location. This will indicate which month will be the most challenging for the solar production to keep up with the load usage. There are resources available for determining the average solar irradiance for a particular location. So what you'll do is fill out this chart for each month, including the design ratio, which is simply the second column divided by the third column. And the critical design month is the month with the highest design ratio. And this is the worst case scenario that you base your battery and array sizing on. The battery size will need to meet the system voltage and amp hour requirements for the loads. The nominal battery voltage depends on the voltage requirements of the loads. The controller selection and string sizing options will depend on whether it's a 12, 24, or 48 volt battery system. You can convert the daily watt-hour load requirements to daily amp-hour requirements of the battery. To account for cloudy weather, the battery bank will need to be sized larger for multiple days of autonomy. This means that the system can operate for a few days when there is very low solar production. Using 100% of the battery capacity will generally reduce the cycle life of the battery bank. Therefore, it's important to limit the depth of discharge of the battery, which reduces the usable amp hour capacity. So for example, 70% allowable depth of discharge of a 100 amp hour battery means that the usable capacity is only 70 amp hours. There are several other factors that need to be taken into account when sizing the battery bank, including battery efficiency, weighted operating time, discharge rates, and minimum temperature. Once you've selected a battery model and determined the battery bank voltage and amp hour requirements, the battery bank size will be determined. Battery bank will consist of batteries connected in series to meet the system voltage and connections in parallel to meet the amp hour requirements. For small systems, there might only be a single 12-volt battery, but for larger systems, several batteries will be required. This diagram shows 4 12-volt batteries in series for a 48-volt system and 2 battery strings in parallel for 2 times the amp hour rating of the battery. Battery chemistry can affect your string sizer inputs and results. Your lead acid minimum and maximum voltages are often 23 and 30, whereas lithium minimum and maximum voltages are usually 24 and 29, and we'll see that a little bit later in this slide deck. For the array sizing, we'll start with the average daily energy consumption from the load analysis. The array sizing is done with watts for MPPT controllers and amps for PWM controllers. Then we factor in the array orientation and insulation for the location in order to calculate the array size. Other factors that need to be considered are shading and derating due to soiling, voltage drop, efficiency, and other factors. We're not going to discuss all the details about how the array size is calculated, as it's beyond the scope of this presentation, but one of our distributors can certainly help you with your array sizing so you can determine the number of modules at a given power rating required for your system. From there, you can choose module brands and their specs to input into the string calculator in order to see optimal series and parallel string configurations and related nodes. As an example, here's a solar array with 4 strings of 2. This means that there are 2 modules in series per string and 4 strings in parallel. The number of modules in series times the module voltage rating will be the voltage of the array. And the number of strings in parallel times the module current rating will be the array current. The array power is simply the module power rating times the total number of modules. These are the parameters that need to be considered when sizing the PV array. When choosing a charge controller, you have to know the following specs associated with your controller and whether they meet the requirements of your system. And they include your controller's VOC limit, current requirements, power requirements, operating temperature, certifications, and other features. And then lastly, you have to choose whether a PWM or pulse width modulation or MPPT, which is maximum power point tracking controller. You have to see which one is best for your system. And the next slide has a chart that can help out with this choice of PWM versus MPPT controller. So you see on this chart, this can help you decide whether you want to use PWM or an MPPT controller. PWM controllers tend to be smaller and they operate at battery voltage, whereas MPPT controllers operate at the maximum power voltage. This maximizes the amount of power being produced, which becomes more significant in colder conditions when the array voltages get increasingly higher than the battery voltage. MPPT controllers can also operate with much higher voltages and lower array currents, which can mean fewer strings in parallel and smaller wire sizes since there's less voltage drop. PWM controllers need to be used with arrays that are matched with the battery voltage, which limits what modules can be used. And here's a very important point I want to make. There are many 60-cell modules with VMP equal to about 30 volts, which are simply generally, or in many cases, not compatible with PWM controllers. The advantages of MPPT over PWM controllers come at a cost. So sometimes you might want to use or choose a PWM controller for smaller systems and in warm climates where the MPPT boost is not as significant. And on this slide, I listed every Morningstar charge controller name. And on the slides attached to your webinar handout, I also listed every SKU and associated specs for each of these controllers. This is a long list that includes PWM and MPPT controllers in our professional series in orange and our essential series in green. And in your handouts, I listed the battery voltages and amperages for each controller model, as well as other metrics and information that will help you choose the right charge controller for your system and input it into the string sizing calculator. Now that we took you through the system sizing overview, we can show you how to use the string sizing calculator. So to access and use the string sizing calculator, I'm just going to go to string-calculator.morningstarcorp.com. Of course, you could go to our website, like I showed earlier, and go to our product pages, and you can access it that way as well. Let's just show you what this looks like. Well, first, I'm going to share with you the information that needs to be entered into the string calculator. First, you need to select the module from the database or enter module data manually. Then you're going to select the Morningstar controller that you want to use. After that, you're going to enter the battery minimum and maximum voltages. And finally, enter the historic high and low temperature data for the site. First input you'll be directed to put in is the PV module manufacturer and model. To input manufacturer and module model, you can search or scroll our database of modules by manufacturer. And after you've done that and chosen manufacturer, you can search or scroll to find the model number of your module. Otherwise, if you know your PV module model number, you can click the orange module search text and start to input it to find and choose your module in the database. As an example here, I searched for KDE M60-EA, and then I chose the module that is circled on this slide. Lastly, if the module you want to use is not included in our database, you can manually input module specifications by clicking on the orange text that you see circled in the lower right of this slide. Fields with asterisks they require an input, and you can get this information from the spec sheet for your particular module. If you're unsure about any of the inputs, you can hover over the question mark associated with that input to get more information. And you're going to need to pay careful attention to enter the data measured at STC, which is standard temperature conditions, and not the data measured at NOCT, which is the normal operating cell temperature from the module data sheet. So important to look at the STC information. The NOTC and VOC need to be entered correctly also, as it will affect the results. And it's important to input your VOC coefficients so that the string calculator adjusts the module's VOC to reflect the temperature effect at your system's location. Your module operating open circuit voltage at your system location with cold temperatures can be several volts higher than when it is at 25C. And this voltage increase is multiplied when you connect modules in series. VOC coefficients are provided in percent volts per degree C these days, and at one time, volts per degree C was more common, so you want to toggle between these two choices appropriately. Here I'm inputting the Morningstar charge controller that I've selected to use for my application. I want to use the ProStar MPPT 40 amp controller. So when I start to type ProStar, my relevant choices start to appear, and I click on the ProStar MPPT 40. Once I make my selection, I see the maximum battery current and supported nominal battery voltages that are supported by this controller. As a reminder, just in case this controller's current and voltage specs don't comport with the requirements of my off-grid system. With my charge controller selected, I then enter the battery system voltage and historical temperature data. For the 24-volt nominal battery that I'm using, I entered 23 as the minimum battery voltage and 30 volts as the maximum battery voltage according to the recommendations on this string sizer application. If you have any questions about this when you're inputting values for your 12, 24, or 48-volt battery, you can always hover over the question mark icon right here and right here to see recommendations. For most lead acid batteries, 23 and 30 are good minimum and maximum inputs. For lithium batteries, your inputs would probably be better set at 24 and 29. And regarding the temperature inputs on the right, it's usually easy to find the historic low temperature for your site location by doing a Google search. And in this example, I inputted -15 degrees C. And you can change to Fahrenheit units if you wish. The average high temperature input is requesting you to input the average daily high temperature on the warmest month of the year for your location. Let me repeat that. It's the average daily high temperature on the warmest month of the year for your location. I'm usually able to get this by searching the city and state or country in Wikipedia and scrolling down to the climate section. Historical weather data is also available on some of the weather websites. Then I click Calculate to see the different types of string configurations that can support my system. Please note that the results will not be displayed if there are missing fields or conflicts with the data entered, such as a mismatch between the battery voltage and the voltages that the controller can support. Calculation results display the PV module name and solar controller model that was selected. We already saw the module and controller specs on the left when we entered them before. Results on the right are new, however, and they're associated with the module's operation for the historical site temperatures that we entered. We'll take a closer look at these results on the next slide. The results on the right. Let's go ahead and take a look at them. If I forward the slide. Here we go. Here's a closer look at the specs at high and low temperatures. The open circuit voltages are shown first. The maximum VOC at record low temperature is the highest voltage that the module might be able to generate, so it's very important consideration. The minimum VMP at the average high temperature is also an important consideration since it indicates the lowest voltage that the module will generate maximum power. You can see there's a big difference in the minimum and maximum voltages when you compare the average high temperature versus record low temperature. There's a big difference between these voltages and the voltages on the module spec sheet, which are based on a 25C temperature. You can see that there's almost a 9-volt difference between the minimum and maximum VOC here, and more than a 6-volt difference with the maximum power voltage. The operational voltage range will determine the range for how many modules you can connect in series for strings of the array. Below the module and controller data is the results table, which provides the sizing options. The number of modules in series for each string is displayed on the left. Each row has a different string size. The number of strings in parallel are displayed from left to right in the columns. You see the array operational voltages are calculated on the right. Each cell of the table indicates the total power of the array for that particular string size. From these results, you'll want to select an array size that meets your array sizing requirements that you calculated earlier. Watts for MPPT controllers and amps for PWM controllers. In this example with MPPT controller results, you would select an array power that meets the power requirements of the array that you had calculated. PWM sizing results will only include a single row which matches the nominal voltage of the battery. Total array current will be equal to the number of strings in parallel times the module current rating. You can quickly calculate the array current or select a cell to review the array current on the results page in order to determine the number of parallel strings you need to meet the array current requirements for PWM controllers. The cells are color-coded to indicate optimal, marginal, and potentially problematic results. We're going to talk more about that in the upcoming slides. If you hover over a cell in the table, it will display more information. As you might have guessed, the green numbers are associated with optimal array configurations, and the blue number in this example indicates a configuration that can be used, but it's moderately oversized. We'll go over all the color codes shortly, but right now I'm going to let you know that if you click on any of the results, it will open a new tab for the calculation results page for that particular configuration. So if we click on this green 1000 cell, it will open the results page on a new tab. We'll take a look at that on the next slide. Calculation results page displays all the information about the solar array configuration that we selected from the table. A nice feature of the results page is that it's easy to print out. You can print out the entire array information. On the top left side of the page, you can see the PV module and controller models that were selected, as well as the system information that was entered. The configuration on the right spells out the number of modules in series, number of strings, and the total watts. And the information note below is very useful since it's a complete description of what was indicated with the cover text, and it includes more information about potential considerations associated with the result. The left side of the results page also displays the PV module and controller specs. On the right, you see additional information about the array. Voltage info includes the relation of the string voltages with the minimum and maximum input voltages of the system. Total array current information wasn't included on the main calculator page, but it is available here. Below the results table, or I should say below the table on your results page, is the string results legend. Here's more information about the color codes. Green indicates an optimal configuration. Blue indicates that reduction of solar production is possible, but likely to be limited and potentially non-problematic. You can see that the list goes from optimal to most problematic. Brown indicates reduced solar production, which may be found to be problematic. There would be a risk of marginal performance and or operational alarms. And then red indicates problematic results, which may cause operational faults or damage to the controller. As I mentioned previously, the optimal configurations are displayed as green, but there are a few things to understand about these options. Optimal indicates that the array voltages are in an acceptable range and will harvest full power from the array. However, undersized configurations show up as optimal. So in this example, we use a TriStar MPPT controller in this example, and the nominal max power is 1600 watts. If you look at that, the data sheet for that product. But on this string calculator results page, it shows smaller power levels as optimal. You can see here, all these are lower than 1600, which is on the data sheet of the TriStar MPPT. They are optimal as far as the string calculator is concerned, but they might be below what you calculated earlier in your array design calculations. For MPPT controllers, higher voltages will have fewer strings, but more modules in series. So you have, for example, 2 strings of 3 will equal 1500 watts. And lower voltages will have more strings and fewer modules. So over here you have more strings, you have 3 strings, and then 2 modules in series. For PWM controllers, the string calculator results will show acceptable sizing up to max power current that's less than the current rating of the controller. Array open circuit current should be less than the controller current rating. Maximum array current may be affected by location and tilt. Higher altitude, reflections, angle of incidence can all affect this. However, Morningstar PWM controllers have 25% overcurrent protection, making it possible to size the controller without applying the 125% factor to short circuit current required by NEC code. As promised earlier, here is the complete string results legend with all the hover text indications. Let's look at the voltage and overcurrent warnings and also the MPPT power indications a little more closely. So I'm going to advance to the next slide so we can take a closer look at them. Here's the voltage warnings. See that marginal performance in hot ambient temperature is indicated for strings where the minimum VMP of the array may be too low and less than max battery voltage, which is regulation voltage during absorption or equalizing charging of the battery system. This is calculated based on the highest amount or highest average ambient temperature. A better module configuration that produces higher voltage should be used to ensure adequate charging over the entire expected ambient temperature range. This result is most often associated with 60-cell PV modules with 24-volt or 48-volt systems. If you click on a cell of the results page that has this warning, you'll be directed to a technical document called Morningstar Solar Controller System Sizing with 60-cell modules. And this doc will explain why 60-cell modules are often not suitable for PWM controllers and why they can be used with higher voltage configurations with MPPT controllers. The warning you see in blue, maximum operational input voltage may be exceeded on near record cold mornings. This will only be displayed with the TriStar MPPT 600-volt controller, and that's because the maximum operating voltage is less than the max VOC voltage for the TriStar MPPT 600-volt controller. The third warning, array VOC is close to max input voltage on record cold mornings. Lets you know that you're getting close to the max input voltage for the controller. Maximum input voltage exceeding on or near record cold mornings. This is a warning that the array voltage could exceed the max input voltage of the controller. And then the last warning, invalid configuration, insufficient array voltage is displayed with PWM controllers when the VMP is way too low. Here we're taking a look at the overcurrent warnings. The first overcurrent warning is for PWM controllers and is indicated for when the max power current exceeds the max input current rating of the controller, which might damage the controller. The second overcurrent warning only relates to the TriStar MPPT 600 volt controller, which has a max operating input current rating of 15 amps. TriStar MPPT 600 volt will continue to operate, but will limit the input current from the array to 15 amps. It's important to recognize this input current limit as it might limit the solar production for your system. For MPPT controllers, the string sizing calculator will indicate when the array power exceeds the nominal max power rating of the controller. Max power is based on the battery voltage and max charge current rating, so it will vary during operation. Moderate oversizing description in blue is often considered acceptable to provide additional energy early and late in the day or on days with intermittent sun and cloudiness. However, the significant oversizing you see in brown text, this would typically not be advisable because reach a point of diminishing returns where the cost for deploying additional modules isn't worth the small amount of additional energy that they're able to deliver. So to sum things up, string sizing is one of several steps in your total system sizing process after your load calculations, battery sizing, array sizing, and charge controller selection. And the Morningstar string sizing tool can help you determine and verify your array sizing and charge controller selection. Morningstar string calculator has over 100,000 module brands and models in its database, and it gets updated on a quarterly basis. If the specs for a module model are not in our database, you can manually enter your specs. Calculator allows you to size your array for any Morningstar controller and quickly access results output that includes optimum module series and parallel configurations. String calculator page also provides notes about acceptable oversized configurations and alerts about configurations that can be problematic and harmful to your charge controller and other system components. And then finally, the calculator provides a printable results page for your specific solar array. This is a very useful document for your solar PV system. And with that, it looks like we've come to the Q&A session. So Doug, I'm going to go ahead and ask you to take yourself off mute. And if you could let me know if we've had any questions that have come in from the audience.
Sure. There's been a lot of really good questions. There's a couple guys asking about whether we'll provide this in Spanish, and I'm not sure if we're going to be providing in Spanish, but we can follow up with questions. We have people that can answer questions from anybody that needs answers in Spanish.
Yep, sounds like a good idea to me. I think we'll get working on that.
And then, as usual, people were asking about handouts or the email follow-up. As you indicated, the handouts are available in the tab on and the for the PDF of the slides, and we'll also be doing a follow-up email. So there's Mark asked, does Morningstar have or can recommend any spreadsheets to help with the first four steps: load analysis, battery bank sizing, array sizing, and the solar charge controller selection? So I know there's a good one available with the book Photovoltaic Systems by James Dunlop, and you can also do a Google search. I think I found a couple there when I did a Google search for off-grid solar sizing spreadsheet or something like that. Now,
I see a question here. Oh, go ahead, Doug. Sorry.
Mark also had another question, which was really good, and a feature we didn't even discuss. He asked, if you add your own module specs in the string sizing tool, is the information saved for future uses? So the information isn't actually saved, but you can make, after you make the calculation, you can save that link, which when you use that link again, it will populate that search result. So any search result you do, if you want to just share it with someone, send them that link and they'll be able to see exactly what you saw. You can save it for later. You can use it anytime. You might be able to even put in location-specific data that you don't have to re-enter every time. You just go to that link and modify the modules. So it also saves the module data and other data that you entered, and then you can recalculate if there's any different changes to the system or the location and that kind of thing. So that's really handy. So that's nice. You can go back to any calculation you've made and also send the links to the results page.
Hey, I see thanks for that question and answer, Doug. I see a question from Randy. Mentions that, yes, I see you support working with lithium-ion batteries. I know you work with Simplify. What about Discover Battery? Want to take that, Doug?
Sure. We have on our energy storage partner program. You'll see it on the main page of our website. You'll see our energy storage partner program, and you'll see it also in the resources tab. And from there, you'll see many different lithium battery manufacturers that we've worked with and been able to provide custom programming, custom settings for their battery specifically that we worked with those manufacturers to provide.
Yep, so we definitely work with Discover and we have about 20 other batteries on that ESP page. That's the Energy Storage Partner page. And like Doug was saying, if you go to our website, morningstarcorp.com, then go to the resources section, that tab, I think it's about the 5th tab down. You just pick Energy Storage Partner program and you click on that, and then you'll see all the logos and all the different brands that we work with, and you can click on any one of those brands to get an implementation guide that will give you information about the specs that you'll have to use for your charge controller to set your absorption voltages and float voltages to make sure that you're optimizing your charging for that particular battery brand. So great, thanks. That's a great question. Let's see what else we have.
I just want to mention that someone asked about our Essential series, where to find it on our website.
Yep.
Go to the top
Dan
right,
asked a question about that.
and
go
if you
ahead.
go to the top right there, you'll see a link. US and Canada does not include those products. The Essential series are on the international site. So if you go to the top right, you'll see US, Canada, or international. If you click on the international, you'll be able to access the Essential series products.
Yeah. So great question here. Depending where you're at in the world, that might not be displaying on your web browser, but if you click up top, like Doug was saying, there's a toggle between US and Canada and another one that says international. So you want to go to the international one. So if you do that, you'll be able to find information about our Essential series products. Great. Let's see what else we got here. Oh, Ronald asked a question. How are the warnings delivered? He's wondering if it's an alert sound at the controller or something else. I don't know. Do you see that question, Doug?
Yes, I do. So that's an interesting question because we have various methods. I mean, all of our controllers, when there's an alert or a fault, especially, you'll see LED indications of there's something going on. with our controllers like the Sun Saver, you wouldn't know exactly what it is. There is a LED section of the manuals that will show you what type of alarm or what different LED indications indicate for all the alarms and the faults that you can look at and refer to what you're seeing on the LED indications. Now, the ProStar MPPTs, the ProStar, all the controllers that have meters will have some indication about what type of fault you're having in our alarm, and you'll be able to scroll to that section using the product meter maps and be able to find exactly what kind of fault you're having. You can also, if you're monitoring your system or if you're remotely accessing it, you can go into and see the live view indications of see it live, or be able to do data monitoring and see it in the data monitoring when different faults occur and when that occurred. As far as the only other way would be with SNMP. It's a way that you can get text messages. It's really advanced. That would be available for the TriStar MPPT or with the EMC1 adapter. So we would cover that in the SNMP webinar when we have that. You can get like email notifications and that kind of thing with the settings there, but that's kind of outside the scope of this webinar.
Perfect. Okay, I'm just looking at some of the questions that we have come in. Gentleman mentioned here that he is colorblind and can't see the color-coded warnings. I guess can't differentiate the red, green, and brown. So that's, thank you for letting us know about that. I don't know if I have an answer for him, Doug, other than let's think about this and see if we might be able to do something with the text there to make something bold or less bold, as well as color differentiate. So
sure,
people do have that. I don't know. Do you have any other suggestions for that, or is that something that we just have to?
Well, and we're hoping to get to that. We're thinking about making a symbol in there, so hopefully we'll be able to add that at some point when we get to working on the site again, possibly. I can't guarantee when that might be. You know, if we'll be able to do that.
Right. Well, thanks. Yeah, thanks for bringing that to our attention. Let's see. Okay, someone's asking Doug. It says, is there additional material on PWM and MPPT controllers?
Yeah, if you do a search on our website, there's a white paper regarding this. If you just search for PWM or MPPT, you'll be able to find it in the search, or I think it's in the resources tab. It's either in the white papers or on the technical documents there.
Yeah, I might add, under the resources, the very first resource listed is what is a solar charge controller? And if you click on that, that has a lot of information. And one of the sections deals with the differences between PWM and MPPT controllers. So yeah, thanks for that question.
Oh, I found another question here that was interesting. Someone was asking about if you have installations with more than one roof, maybe different characteristics. And that would really be up to the design engineer. I mean, this is kind of a very advanced type of situation. Our system, you know, our sizing calculators typically going to be used with a single solar array. Everything's on the same plane, whether it's on a roof or a ground mount system. Typically, everything's in the same plane. All the modules have their same characteristics. Now, if you're on different planes on a roof, and there's different operational, even shading can have ramifications on how to size the array and how to configure it. So you get shading in one part or the other part of the roof. There's ways of optimizing your array sizing, and possibly it may come to the point where you say, well, this array, if you put them all together, it's not going to operate with the same power, and they're going to be off enough where I don't want lose the power or cause, if you have one that's, one of the things about strings, each string should have the same angle and be on the same plane. If you have one that's not, then the one with the lowest current at that given moment, that's why shading can be a problem, is that it will either bypass that, there's bypass circuits, and there is, or it will just limit the power to the lowest current. So we will find either one of these in our MPPT controllers, but the voltage may be too low to just bypass one. So often you're just limiting the current. So, it's something that you'd have to decide on a case-by-case basis and decide whether certain shading, you might want to use 2 different controllers for that system, or how you decide to configure the array so one string isn't going to be treated bad by one module or something, and try to group those together. That would be in the shade. So there's a lot of advanced classes that kind of cover this kind of thing, and that would be something for an advanced solar class to go through all the details on that.
Hey, Doug, I see a question coming in from Victor that asks, and we didn't really go over this in this webinar, but maybe you can answer this for him. He asks, please explain what it means for a panel to have 18% efficiency.
So the efficiency is not really a factor. It's going to be the operational characteristics of the module. So the efficiency is really just a characteristic that won't affect the string sizing. It's the voltages and the current ratings of the control of the module that are going to affect the string sizing. So the efficiency is not going to really affect that.
Okay, very good. Thanks for that question. Thanks for the answer.
There's a quick, interesting question you might know. Is there any license issue if we use the printed report?
Yeah, I see that. Arl asked that. I was going to ask that one for you. Yeah. What's the best way to answer that for him? Oh, you're asking me if I have an answer to that question? Put me on the spot here. So I guess I'd have to know more specifics. I don't think there would be. It says, is there any license issue if we use the printed report of your string calculator with a printed report generated by other software tool for site analyses?
I don't see any problem with that.
I don't see any problem with it. No.
To you for any project or anything.
Yeah, I mean, we don't. Yeah, we're not gonna. We want you to use this. I mean, we're not gonna have any issue with it. It's just, I don't know if anyone else would. I don't think they should, but we certainly wouldn't. All right, that's a good question. Let's see, what's this next question from Shibi coming in?
There's a question about using modules, 24-volt modules with fluctuations up to 38 volts. And a smaller system of less than 6 modules and a battery voltage required for 24 volts, do you recommend PWM or your MPPT? Now, nominal voltage, nominal voltage modules or arrays will often, the VMP will be much higher than the battery voltage at many times. So your boost from getting MPPT is what will be affected. As long as it doesn't go above 60 volts, typically for a 24-volt battery, you can use a PWM. Now, the newer modules are getting up. There used to be a VMP of 36 volts. Now you're saying here that you have one that's 38 volt. In cold temperatures, it's going to go well above 38 volts. And the minimum temperatures, you won't see it go that low. In that case, you're going to get a lot more boost than you would have with older modules that were more like 36 volt VMP. So it's just up to you whether the boost, anytime you're using PWM or MPPT with a nominal voltage array, you're basically considering whether it's worth getting the boost with the MPPT, the added cost of the controller in comparison to the PWM, and also the added boost. So in certain locations in colder weather, that can be significant to get through, help you get through the winter months with an MPPT. PWM, might be, as indicated in our PWM versus MPPT white paper, PWM can often be a good solution or the best solution with nominal voltage systems in warmer climates where the boost won't be as high. And the boost is really the most useful in the winter or the coldest temperatures when you get the highest voltage of the array, and you can track that VMP and get a little bit more boost.
Okay, very good. I'm looking at some other questions that have come in here. Oh, kind of hard. I see one and then another one comes in and just pushes it back. There was a question I saw about, let's see, how can I use dissimilar modules in the same system? That's kind of an interesting question from Jeffrey.
That is a good question. I've helped many customers with this. If they're not the same manufacturer, but the specs are mostly the same, there's not going to be a whole lot of mismatch. I mean, the biggest concern is that there's going to be voltage mismatches, there's going to be current mismatches. There's no real rule saying that you can't do it. If you have a system that's 24 volt nominal and you add another 24 volt nominal panel to it, and because you just want to expand on it and you have the capacity in your controller possibly, there's no problem with doing that. We've had customers do that, and then the mismatch, especially with PWM, is not going to be a problem at all because you're never really operating at the VMP. You're just each string pretty much is just charging by itself. And the biggest problem with MPPT would be that you have to match series connections by modules in series for each string with the same current rating. And if you do parallel strings, all the strings have to be the same voltage. So when you see the strings always show up at this, you can't put, like, for example, 2 modules in one string and 3 modules in another string. That's just not going to work. It's just not going to be able to do that. That's why all the strings are the same length. You have to have multiples of the same number of modules per string. Same kind of thing. The numbers of strings affects the voltage. The numbers of modules in series affects the voltage. So that's where having the same voltage in any parallel strings is really important. And the amount it will be off would really, you want to talk to a experienced designer or look at it and consider how much it would affect your production. The more it's off, the more you're going to lose power. In series, you'll lose the current. You'll go to the lowest current. In parallel, it's going to be a mismatch, and the tracking is going to be off. It's not going to be at the VMP.
All right, we had a module question. Now let me go to an inverter question. The question here is, do you list inverter manufacturers that work well with your charge controllers? They're making a point. They say, I know you have listed battery manufacturers on your website that we work with. Do you list inverter manufacturers that work well with your charge controllers?
No, we don't have a list. It's our controllers work with any type of battery. I mean, there's a couple of questions here about battery manufacturers. What do you have listed battery manufacturers? We really don't have a list of all the battery manufacturers. We were considering the possibility of listing having a list of battery manufacturers. I've worked on that to some extent, but it's far from complete. But we're thinking about that and just showing all the set points for those models, model by model. Yeah. That's quite a job. We don't have that.
I think that's the key. But, yeah, that's the key. Like you said, Doug. Yeah, we work with virtually all.
Yeah, but if we have time to do everything we want to do, we'd love to do that someday. The inverters are pretty much, if it's operating, it's just a load. It's just like any other load. It has to have its own load disconnect, load control, LVD, or we don't have any controllers that you can use the load circuit for an inverter. It's going to be, the surges are just way too high for our controllers. So you can't use the load circuit with any inverter, or DC to DC converter for that matter. It can easily exceed because there's capacitive loads, and you want to be very careful with that. And so we can work with any type of inverter. We've had, you'll see a lot of our projects on our website include many systems that include manufacturers from all over the world. And so a lot of the larger inverter systems, they're going to be installing our controllers with their inverters quite a bit, and we have a lot of systems with those, with every manufacturer of inverter that we support. So you'd want to go to the you'd want to talk to a distributor or dealer as far as what inverters would be available, and they're just made for nominal voltage batteries, and you want to make sure you have the nominal voltage that you need.
All right, very good. Let's see. Question here says, any controller that has load out voltage controller? I think, and I don't want to, I think they mean load control, or you want to take that, Doug?
Yes, well, our controllers are just going to be a switch to the battery. So you're not going to be able to control the voltage with any of our controllers. If you need a particular voltage and you can't work with the battery voltage window, operating window, you would want to use a DC to DC converter. And if it's a very small DC to DC converter, our load control might work with it. Just that, it can be much higher surges than you would have on a typical load. So we do have some information about different types of load on our website, and so you just want to make sure that our load controller would be probably 3 or 4 times higher than the input to your DC to DC converter. Other than that, the DC to DC converter, you'd have to have a low voltage disconnect load control for that. It might be built into the converter, or we offer a relay driver, which you can use with a relay, and that can be used for load control for working with DC to DC converters. We are thinking about at some point making a controller with a voltage regulated output, but at this time we don't make that. We don't have that, but it might be available in a few years or so.
Okay, great. I see a question here. It says, we usually install PWM charge controllers for off-grid solar systems in an IP65 enclosure installed outdoor in the shade of the panels. Summer is hot. Can we install MPPT controllers in IP65 enclosures outdoor?
Yes. One of the considerations, of course, is the heat inside of that enclosure. You want to keep it out of the sun, some kind of shading. We have a white paper. If you go to the resources tab and go to white papers, you'll see the second paper there is called Heat Dissipation of the TriStar and TriStar MPPT Controllers Inside Enclosures. So this shows how to calculate the heat dissipation of the TriStar PWM and MPPT controllers that would be inside of it, and then the calculations for how big, what are the effects for different sized enclosures. Vented enclosures can really help. If that's not possible, then fans might also help it keep cool. But this will give you an idea about what kind of size you need to make that enclosure so the heat dissipation doesn't cause the temperature inside the cabinet to get too high for the controller.
Okay, very good. I had actually a couple questions here about whether our controllers can be used with different types of batteries, and yes, they work with lead acid, lithium, also nickel cadmium, and other battery chemistries. Typically, you'd be looking at 12, 24, and 48 volt battery systems for our charge controllers. And there's a question about the availability of the recording of this webinar. Yes, you'll be receiving that by email tomorrow in a link. And I think we've covered most of them. I think there was one more maybe here, Doug, that I remember seeing. Somebody was asking a question. Oh, it's rather lengthy. Darn it. I hope I can find it now.
So one question here is the question about asking, would it be easier to have the calculator select the charge controller of selecting at the beginning? You can do it at the end. And it's, if you select a charge controller and do the calculation, you can always easily pull down because you can go back to the top and all that information is there. You can change one aspect of what you entered. So if you want to find that your controller isn't big enough, for example, you chose a TriStar MPPT 30, but you really need a 45 to get the size array you wanted, you can go back up, scroll back up, and select the TriStar MPPT 45 and run the calculation again, and it will come out with that controller. So it's not that hard to select the charge controller again, and just change one thing, even if it's the battery temperature or the array, the battery voltages, or any parameter that you want. Change the module if you want, if you find that it's not compatible with your system. So there's a lot of different. It's really easy to go back up and change one setting, one of the inputs.
Okay, let's see. I think we really got through about most of them, Doug. We'll take a second look at these. If there's something we didn't answer, we'll get back to you by email. And let me go to the thank you slide here. Unless, Doug, did you see anything else there that we might have missed?
Yeah, someone was asking about purchasing. Well, we can get back to them.
Yeah, I did. You're right. I did see a couple questions about that. We can, yeah, we'll definitely get back to those folks. Depending on what part of the world they're in, we'll hook them up with the right distributor. And I think somebody was looking for an essential series controller. I think it was Gary. So we'll get back to him about that and some others. Terrific. And somebody did have a shout out to, somebody said they found something online, that string size calculator on the Alt-E store site, altestore.com. Yeah, they're one of their distributors. So somebody found a site there. Mark said that, altestore.com, store calculators, Offgrid calculator. So yep, there's a lot of good resources out there. Okay, so with that, what I'm going to do, Doug, if you're okay with it, I know we've gone a little bit past the hour, but I have the thank you slide up here. If any of the attendees have any additional questions or need us for anything, just go to our website, which is the morningstarcorp.com. And in the upper right, you can contact us for any other needs you might have. So with that, I'm going to close out the webinar. Thanks for joining, and we'll see you next time. Take care. Be safe.